Hello everyone. I, this video I'm talking about the example of constant acceleration motion. Okay, and here's I take the example from a textbook, example 2.3, and the problem is now suppose now you have a jet plane and it's landing on the ground, and at that instant it carried a speed called 270 kilometer per hour. And then once it hit the ground, once he landing on the ground, is he's doing the acceleration, and the value of the acceleration is 4.5 meter per second square. Okay, and the question is, where should I put a question? Question is, what's the minimum? What is the minimum runway distance? Runway distance to stop. Distance to start the jet. Okay, it's a very simple question. A jet is landing, carry the speed 270 kilometer per hour. And how long is the runway to when the jet is completely stopped? Okay, so in this problem, I'm going to use the equation the equation we obtained on last time we for the constant acceleration motion we get the two equation. One is equation of motion, right? The final position equal to the initial position plus initial velocity times t plus 1 over 2 times acceleration and times t squared. And the other is the final velocity square equal to initial velocity square plus 2 times acceleration times displacement. Okay, so for this problem we need to set up something first. First of all, we set the origin on landing here. If I was suppose the jet land here, and we set the origin here, and then we set up the coordinate. Of course, this is a one with when right now we are still talking about 1D kinematics, so the coordinate is only one direction, and I call this x direction, and the right hand side is positive. Right hand side is positive for right hand side. Okay, I hope you understand this notation. Okay, so and then for this problem, what information do we have? We have, let's see, the information of the problem. Okay, so it carried a speed when it's landing 270 kilometer per hour. That's the initial velocity, right? Initial velocity is 200 kilometer per hour. Okay, and right now we have to do a little unit conversion here, because I say in physics we love the MKS system. That means represents all the physical quantity by kilogram, meter, and second. So we have to do a unit conversion. So kilometer means 1,000 meter. And how much second for an hour is 3,600 seconds. So use your calculator. So what's the answer? Use your calculator. 270 times divided by 3. Okay, 75. Okay, the initial velocity is 75. The unit is meter per second. Okay, and so in this problem, what's the final velocity? The final velocity, because the problem is what's the minimum minimum runway distance to stop the jet. Stop the jet, that means your final velocity is 0. Okay, and and then it also give us the acceleration. Okay, acceleration is 4.5. but here we have to one thing we have to be think carefully. And the problem say when it's landing, he's doing a deacceleration, 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 deacceleration. That means your the direction of velocity and acceleration are opposite, are in opposite direction. So that means when the jet is landing, it's going this way. Yeah, when the jet landing, it's going this way. Yeah, but the acceleration goes this way. Okay, so I think it's much clear. Okay, when a jet landing, okay, it goes to right way. Okay, but the acceleration goes to the other way. So in the right direction, and the right direction I set up is positive. Okay, so if the acceleration is pointing to the opposite direction to the left, so that means it's negative. So no, be careful. It should be negative. Okay, in this coordinate system we set in the coordinate in the coordinate we set up, it's negative. Okay, so let's pretty much about the information we have. So which equation we want to which equation we should use, because then right now you have two choice. Uh, if you look at these two equation, looks like we use the second one, seems much better. Okay, we also have another information here. Okay, initial position is 0. Yeah, initial position is 0. Initial position is 0. Yeah, why? Because as I choose a landing spot as the origin, so the initial position is 0. So we get all the information. Looks like the equation 2 is much easier to use, because for the equation 1, we still need the information for the t, right? Yeah, and this problem we don't, and this problem we don't need to solve how much time it will. Yeah, sorry for the equation 1, we need information of time. So when you put all the information in the equation 1, you will find you have two unknowns. Yeah, you have two unknown. One is time, the other is xf. But for the second equation, you put all the information in there, you will find it only have the one unknown left, and it's much easier to it's much easier to solve. So let's use the second equation. Second equation. Okay, so let's put everything in there. So 0 square equal to, oh sorry, 75 square plus 2a. Be careful, it's minus 4.5. And xf we don't know, and xi is 0. So, so let's we rearrange this equation. What do we have? We have 9xf equal to 75 square. So what's the answer? Okay, use your calculator again. I found my calculator. 75 square divided by 9. Okay, 625. And the unit is meter. Okay, be careful. The unit is meter. MKS system, we have already made everything in kilogram, meter, and second. Okay, so that's pretty very easy example for like example 2.3 in the textbook, and we'll stop the video here. And the next video we'll show you another example in the textbook. So see you in the next video. Bye bye. Bye bye. Bye bye. Bye bye. Bye bye. Bye bye. Bye bye.